In this lesson, we're going to take a look at section 2.1 on inductive reasoning. So before we get into defining inductive reasoning, let's just take a look at the warm-up here. So let's look at the sequence of numbers, 2, 4, 7, and 11. And the ... of course, means it's going to go on forever. And I asked the question, what number comes next? And to answer that, you usually have to then identify what is the pattern. So this is a numeric pattern, and if we look 2 to 4, we're adding 2, 4 to 7, we're adding 3, 7 to 11, we're adding 4. So the pattern is to add one more each time. And so then to go from 11 to the next term, we would add 5. So the next term should be 16. Looking at the next pattern, we have 3, 5, 7, and I asked what number comes next and what is the rule or pattern, and then of course, could there be another answer? So taking a look at this from one side, you might say, okay, they're odd numbers, 3, 5, 7, so the next number would be 9 and then 11. But the other thing that these numbers have in common is they're actually all prime as well. So 3, 5, and 7 are all prime numbers, and so 9 is not a prime number, so then the next number would just be 11. And then the next prime would be 13. So sometimes a pattern is really clear, and other times it can be more interpretive depending on what you have. So what we're doing here is we're looking at these specific examples, and we're kind of inferring or recognizing a pattern. And this is the process of inductive reasoning. So I want you to grab a sheet of paper, and we're going to make a formula, make a vocabulary list. So this is for chapter 2. There's not as much vocabulary as there is in chapter 1, so we can kind of just keep a running list. So in this section, we're going to look at inductive reasoning, and we're going to look at the word conjecture. So inductive reasoning is the process of observing data, recognizing patterns, and making generalizations. Meaning a generalization is something that works every time, a rule that works every time. So when I think of inductive reasoning, we're going from something specific, and our goal is to create something general, to describe the pattern that's just happening over and over again. When we do this, we can come up with what's known as a conjecture. So a conjecture is just a, make sure I get this right, a generalization resulting from inductive reasoning. A lot of conjectures take a very specific form. A lot of them come onto conditional statements, and we will define conditional statement in section 2.5. But that's what a conjecture, kind of the form that it takes. So today we're going to be just looking at the idea of inductive reasoning and trying to look at some patterns. Numeric we already looked at, and then there's also some visual patterns we're going to take a look at. So we're going to take a look at some patterns here and generalize to find the 30th term. So looking at this, okay, what patterns do we notice in the first, third, and fifth terms? So the first, third, and fifth terms, they're all circles, right, that are half shaded, and it looks like they're rotated or turned let's see, this is going from here, and then the next term goes here. So, and then from there, the next term goes like this, looking at that. So they're rotated 90 degrees, and we're rotating this way, which would be counterclockwise. And I got pretty specific there. That's a lot of very specific things. So, and those are on the odd, right? 1, 3, 5. On the even, 2, 4, and 6, what pattern do we notice? So first of all, we're starting with a triangle, and then we have a pentagon, and then we have a heptagon. So on the second term, we have something with 3 sides. On the fourth term, we have something with 5 sides. On the sixth term, we have something with 7 sides. Looking at this, so what do we notice in these shapes? So a polygon with, we can say n plus 1 sides. So if n is 2, n plus 1 is 3, 3 plus 1, or 2 plus 1 is 3. A polygon with n plus 1 sides. We have circles in the angles on top and bottom 2, right? And then the top circle is solid. And then we're going to be asked to draw the 7th and 8th shape. So I want you to pause the video, try to draw the 7th and 8th shape, and then take it back up. So the 7th shape is going to be a circle. And since we're rotating the circle 90 degrees in the counterclockwise way, our circle will be like this, and the half that will be shaded will be this half. For the 8th shape, we need a nonagon, so it needs to have 9 sides. A nonagon is not that easy to draw, but I think we can do it. So we want it to have a point at the top. So do like 1, 2, and then 3, 4, 5, 6, 7, 8, 9. Some of my angles there got a little bit lost. And then we're going to have that open circle, and then, oops, the solid circles on top, and these open circles down there. So this is really interesting because we're asked to draw the 25th shape. So now what we need to do is we need to start, again, thinking about how this pattern is repeating itself. So we know the 25th shape is going to be a what? It's going to be a circle because it's on the odd. Now the next thing to decide is where it's going to be shaded. So let's look. We started with the top half at 1, and then we moved to the left half, bottom, right half. So then at 1, 3, 5, 7 at the, excuse me, yes, at the 9th, we're going to actually start back over, right? We'll be back at the top. So then it will be the 9th, and then the 11th, and then it'll be, the bottom will be the 13th, and then the left will be the 15th, and then we'll start back over. And then starting back over will be the 17th, and then the 19th, 21, 23. And so that means when we think about number 25, we'll actually be starting back over. So it will look just like the first shape. And then for this, it says describe the 30th shape. So because, again, it's going to be really hard to draw this polygon, it will have 31 sides, and then with the circles. So again, patterns can be really visual. Geometry is a really visual subject, but geometry also has, of course, the numeric component because it's math. And so we want to be able to do both. So I want you to look at these next 3 examples, and we will discuss them when we meet, but I want you to try them. So I want you to draw the next 2 consecutive terms, consecutive meaning one after the other. So draw the next 2 terms, so draw the 4th term and the 5th term. And then I want you to think about describing the 25th term. So when you do that, when you describe the 25th term, you can kind of do like a sort of sketch if you want. So for example, if you're trying to count blocks, for example, if we went something that was like 1 block, 2 blocks, 3 blocks, and if you were trying to do 25 blocks, it's okay if you kind of do something like blocks and then like dots and then blocks, and you can draw like 25. So you can sort of sketch it out a little bit. All right, and then also try the